Mr.
Yes, sir. Yes, sir.
Okay.
Excuse me, sir.
Hello.
Sir, can I ask one doubt or should I wait for the meeting to start?
Yeah,
So,
let's wait. Let's wait. Just
one general thing, continuation of the same topic.
okay.
These live sessions are really helpful, but this timing is little inconvenient. This particularly today's, is it possible to change it to 6:30 at least? Half an hour. Can you means is there a
Yes, sir. Because for working professionals,
Mhm.
there is a
reaching
traveling
home
time.
at 6 o'clock is
There is a traveling time, sir, from office to home.
Yes,
And,
commuting time. Actually, ideally speaking, 7 o'clock. But if we tell 7 o'clock, then again it will be rejected. So, and the Saturday session is correct. It is okay. And the Tuesday 8 o'clock session is also fine. But this only one session, is there a possibility? Can you please think over?
Okay. Yeah, most sessions are we kept as so that every can
Yeah, only this session is at 6
So
o'clock.
my office ends at 7.
But
And by the time I reach home, it is
My
8
office
o'clock.
ends at 9.
Sir, stat session
See?
is also there, no, sir. So that is from 8 o'clock,
yes, sir.
8
If
to
we
10
have
o'clock.
back-to-back sessions, then
oh, Friday.
in the
Friday
previous
stat
term we
session is
attended
there.
This
sessions
is
from
fine,
8 to
sir.
10 also.
Okay, so I'm looking. Most of you are fine with this
6:30 is
timing.
6:30 at least 6:30 to if possible.
So let's see. If you are giving this message, I will pass out to operation team. They will decide. Yeah, okay.
As Madam suggested, subsequently even the statistics also can be postponed to 8:30. Means
So okay, I don't know for state, but I know for maths.
yeah,
Okay,
yeah, yeah,
pass
yeah.
it. I will
Understood.
pass out the message. They will decide the timing will change or not.
Okay.
Okay.
Yeah, I think the challenge will be if you push stats to 8:30, there will be 8:30 to 10:30. So that may
Yeah.
become too late. So anyway, I mean, I think the feedback is captured, and let's see what the ops team will decide.
Okay. You can evaluate, but 6 o'clock is okay. Fine.
Sir, it is for working professional. We wanted to attend this live session because it is very useful. Earlier, it was like last term, it was like evening 4 o'clock that we was not able to attend working professional. That's why I requested them, could you please do it in the evening? So though they have did like 6 to 8 and 8 to 10, but some are telling it's like 6:30. Some of we all working professional wants this live session.
Yeah, there is
yes.
no doubt about it.
So we wanted that interactive session. See, rather like any 1 or 2 times we can miss out and see the YouTube, but we all expecting this live session is more useful for working class people. It is very useful. So we don't want to miss out this.
Miss out. And one more
Yes,
option,
sir.
sir. If you
It is
don't mind.
more useful than the lectures.
Exactly.
Yeah. We can be very blunt in telling that. But sir, unfortunately, this morning, why you are not evaluating, sir? Morning, maybe at 5 o'clock.
5 o'clock.
Yeah. Why not, sir? No, why not, sir? No, nothing.
Krishnan, sir.
No,
Sir, we can come, sir, but teaching
only one
faculty
person.
should come. No, you should think in that aspect.
Work from home, if it is work from home for you, Shubham, why can't it be evaluated?
But 5 o'clock would not be possible for
See,
everyone.
first
right?
thing, let you know that first thing. See, for all of you, always not all session able to be like the good time. So see, if you are attending at least 2 or at least 1, please come to that time and ask. You see, if you all ask, we will never say that I will not introduce
Okay,
you.
you people can decide, sir. Fine.
Yeah. So that's why we made timing night 8 to 10 also, so that working professional can join also.
Yeah.
So see, all of you are not always possible to join all session. See, there are so many sessions also. 4 courses are here for this second term. So I hope, see, for someone the best time is 6 o'clock, for someone the best time is for 8 o'clock, someone
Exactly,
for 2
sir.
o'clock.
What we can also view the recordings on YouTube, right?
Yeah,
That
see, you
would be-
can
that
watch
is also
the,
helpful.
you can see the recordings on YouTube. So note and doubts. If you have still doubts, please note that. And whenever you are able to available in some particular live session, go to there, ask your doubt. Surely it will see whoever will be taking that session. Surely will introduce your doubt. So
So we
don't
can
worry.
we can even post our questions or queries on Discord also.
Discourse also. Yeah.
Okay, sir. Just to cut short, possible 6:30. You please consider. That's it.
Yeah. Okay. So yeah, I will pass to the operation team. Okay. Don't worry.
Sir, one more thing. Before the qualifier process, when we used to attend, so there were at that time there were like many practice assignments. Now I'm seeing it has like decreased. Is there any reason for that? Like there are bunches of activity questions, but the practice assignment one I'm talking about.
No, it is not decreased. As usual, maths 2 is reading as usual as
Like
from the
for
first.
maths 2 in week 1 we have only one practice assignment.
So it is only one always from the beginning. It is. See, if
So,
there is will be practice assignment or some question, it will be given to you in an activity. It is added to in activity. Yeah, the practice will be one, so that you can infer with this practice to the map to the graded assignment and try to solve. That's the one. See, there will be more practice assignment. You will be may confused. So whatever the extra question will be, that given in activity. So that's why there is only one practice assignment. So don't worry with that.
okay.
Yeah. Practice is also one kind of activity, but yeah, you need to be attend yourself and then get the idea to do the graded.
Sir, can I ask one question about quiz one?
Okay.
Sir, last year also the quiz one was dated on such a day that it was clashing with UPSC civil services examination. This year also it is the same case. It is clashing with UPSC civil services examination.
5th June, 5 June, is it?
Yes, 5th of June. Last year also it was clashing. This year it is also clashing. If you can please pass this information, they can take care that this examination does not clash.
Okay, but yeah, this calendar is totally. See, these things deal with the main coordinator and Sir Andrew Sir, Bharti ma'am. I can tell, but yeah, let's see. See, they are looking also. See how much possibility can they used to be. See, not only the putting the particular date. See, the exam is also in online. So and taken by the TCS. So TCS will sometime also make the restriction which days will be possible to take the exam. So because of that, these things are deal with this higher authority. So I don't know.
So what
They
happens,
used
sir?
to be looking.
I have to make a compromise whether I attend IIT Madras examination or civil services examination. Last year also the same conundrum. I had to drop, first quiz.
So I don't know. Okay, well, yeah. See, whatever you will say, I will surely pass out the messages. But I don't know. See, it's totally up to them. They will decide how it will go. All things I don't know.
Yes, sir. Please at least make them aware that this is one of the issues.
Yeah. I will also pass out this message to the high authority.
Thank you, sir. Thank you very much.
Okay, so I'm looking some in chat. Please give solutions. So see, of activity question. See, activity question, I will say not to give the solution. How much you will discuss in yourself with the group, you will learn more and more. See, if you are facing difficulty to solve activity question, post in Discord. See, there is not, we are not answering or someone is not answering. There are so many students is also answering, giving the different idea how you will solve. So giving the solution of activity, I think it is not a good to learn, and not a good way to learn. Discussing about that is a more important. So that's I will say. And okay, so and one thing how many participants are here? Okay. And one thing I want to say, all of you have gone through the orientation session of Maths 2, and I hope how to approach Maths 2. Now see, in previous two term, Maths 2 was like a big syllabus in Maths 2 was, but now it is separated, like calculus part is shifted to Maths 1. Now in Maths 2 have enough time and not a big syllabus. Yeah, this is an abstract notion, like vector space is a totally new to all of you. Most of you, not all of you, most of you who is not from maths background are not doing BSc in mathematics or not doing engineering also something. So
Computer science engineers are familiar with vector spaces.
Sir, can you come again? Like which
Sir,
software is
orientation.
it?
Sir, orientation program video I'm unable to open, sir. I didn't
So
start.
that's not a clickable link there.
yeah, actually, yeah, I also faced the issue. Yeah, okay. So I thought maybe for me it's I am
Yeah,
facing
that's
the
not a
issue.
clickable link. That there is a link there, but that's not clickable.
Yeah. So yeah, actually, yeah, I also facing
So,
it now.
so is it in the portal? Is it in the portal that you are clicking or in the mail?
In portal is
Yeah, in portal is only there.
The portal it's
Only in
working. I mean,
portal.
yeah, in portal it was working for me.
Oh, so
Not for me.
so the second thing is you can do, you can you all of you, I think, who is doing this course have joined the YouTube channel of IIT Madras. Yeah, I will say this about this portal. I am also facing issue. Yeah, second thing you can do, you can go with this YouTube channel of IIT Madras online degree and search the orientation video of mastery. You can easily get. See, I am also search this. Let me share the screen first, so then you can see also. So I also did like I like this.
And so, who all will be teaching this maths too? You and who others?
So yeah, maths 2 is in this course the instructor will be there are about like me, Subhajit and
Like
Susmit.
Vicky sir told that he will teach.
Vicky sir. Okay, so yeah, if he will, yeah, he was saying, so if he will get time apart from maths 1, he will surely. I don't know.
Okay.
Yeah, but the main instructor in maths 2 will be Subhajit, me, Subham, and Susmit.
Okay. Okay.
Multivariable calculus is also removed from Maths 2.
Sorry.
Multivariable calculus is also removed from Maths 2, sir.
No, it will not be, because multivariable is needed. So for multivariable, the matrix and system of linear equation, or I will say vector spaces is needed. So
Can we start?
So for that, it will be not shifted to some other course.
Sir, activity question
Vector
1.3.
spaces is related to multivariable calculus. I mean, yes, sir.
So multivariable needed this vector matrix about the matrix. Yeah, to know what are the theories related to matrix needed for the matrix.
Excuse me, sir. So we were not taught calculus in maths 1. So basically, I don't know calculus.
Yeah, but the clear instruction is given that you have to be gone through. See, now this maths 2 is second time running. Like math 1 is already once the calculus part is done. So if you are not done, you have to watch the videos, and then otherwise
for the previous time it was suffered.
It is not like mandatory to do, but yeah, you have to be very, like you have to be comfort with the calculus part, then you are able to do multivariable.
Okay, then like I have to go through all those videos, because we were not given these videos in maths 1 basically.
The previous time it was given. Previous time calculus one.
No, like I passed my first term, but I didn't do calculus.
Me too. Week 7, 6 for calculus only.
Yeah,
the integration and everything.
Yeah, exactly.
Okay, so this is all about okay, so please do the course. And the second thing, and let me tell you again the process for doing the maths 2 will make it easier to understand. the first thing is first see the video lecture. Yeah.
Excuse me, sir, I'm getting a little confused. Like I passed my first like maths and English in August. Yes, August 21, and we were not taught
That time there was not.
Sir, at that time, actually, Maths 1 syllabus was not included. Like,
Yeah, first two term or till 3 terms there was not in
Yes,
the
from
calculus.
January it was
From
included.
January 22,
Yeah.
calculus is included in Maths 1. That is why you missed it.
Okay, okay. So these lectures are there somewhere.
Yeah.
In the YouTube
It's
only.
there.
Okay, okay.
Playlist.
So the last time, this last time, previous term, we also given a link here, the contents, whatever the for calculus. After week 3, we given the link in the portal itself for maths 2. This time maybe also we will try to give the portal who didn't attend the calculus part will also get. So
Yes, yes, sir. Please do. Thank you, sir.
I have one question. May I interrupt for just a few seconds? I'm new to the course. I just want to understand by when this week's assignments have to be submitted. Should it be before the end of the week, or how is that?
Or
How
not
does this
before
work?
11th.
See, every Wednesday is the deadline,
yeah,
basically, for each week. So the coming week, Wednesday will be the deadline for the first assignment.
Thank you.
yeah.
Thank you. Thank you.
And
That
you,
helps.
see, when the new week is started, please see the deadline of, like, just open the graded assignments and at least see where is the, what is the date for. Please confirm with that. Here is written already, right? Which date it will be the due date.
Yeah, sometimes a date will be prior.
Hello,
Not
sir.
always 1 week.
So please, whenever the new week is started, please open the graded and see which date is the due date for the particular graded.
Thank you. Thank you. I was going in a sequence, so I did not really open the graded assignment. That's the reason. Sorry.
Okay, so this is
Let
all
us start
about
with activity questions. Before that, sir, you were saying something about the techniques to
approach.
learn math too.
Approach to learn maths 2. Yes.
Approach to math. Yeah. So let me continue with that. So the thing is, I have we have introduced about this, how to approach maths 2. Let me repeat it again. So the thing is, just watch first video lecture. Watching the video lecture is up to you. My suggestion is to note down whatever the formulas are. Make your own note, and then before going to the activity question, first go to the solve with assignment. This solve with assignment. This is a very useful assignment. And why I'm saying, see, you will see here the keywords, whatever taught in the video lecture, and the exact keyword will be uses in this. There are some question, maybe one question will be, or 2-3 question, maybe more also. So directly apply those keywords or whatever you can infer with the video lecture direct to the question, and then move to the activity question. This is the best thing. Then you will see that then video lecture will be more understandable with if you approach with this way. So don't miss the solve with assignment. See why I'm saying also, here is the, if you click here, it will give some message where you are doing mistakes, or there will be a feedback, means I want to say there are.
Your screen is very small, sir. We are not able to see.
My screen is it?
No, for me it's proper.
Yeah, just pin my my screen is there, has just been to your laptop. So see, what I'm saying, there are some feedbacks. If you are missing, or you are doing, or you are choosing wrong option, it will give you a feedback where you are.
You are talking about the activity question or the
solve with assignment. I'm saying solve with.
Okay.
So you will get a feedback where you, if you are correct, then maybe also there are some feedback. If you are making mistake, there are also some feedback you will get. So that.
Sir, I just wanted to ask that these elementary transformations which are there for row and column, so those are not covered in the videos, but are there any questions whether we can solve it without the transformations?
Transformation, elementary row operation, column operation.
Yeah, those are not covered in the videos actually.
No, it is covered in video lecture part 1, determinant, in the last.
Sorry?
In this part here, you can what are the effects when you do the row operation or column operation.
Yeah, this converts.
So and
Just
also
click on. Can we start discussing some questions?
Sir,
Yeah, sure,
sir,
sure. Let's see.
sir, you
Slowly.
mean to say the approach is from first watch the video, then go solve with us,
Solve
and
with
then do the non-graded activity assignment, is it? It's not
Then
like you watch the video and then do the each has its activity questions and then go to the video, next video, then activity assignment. Nothing like that.
It's totally up to you, but the best way is, see, before solving the activity, just go to the solve. This
Anyone
is
having
totally up to you. This is totally up
maths
to you
in
how
this
you want.
term?
Okay.
Let me please let me clear that. I will take the question. Just this is the first session. I am telling the processes are, so don't worry. I will take everyone's doubt and surely will deal with here. So don't worry with it. Okay. So yeah. So I was continuing with this. So you will get the feedbacks. And yeah, see, if you are like the simple thing is asking for the effect on determinant. What are the, like, if you do the row operation. So see here the keywords is also regarding the when you do the operations, row operation, what will be the effect on the determinant. It will written here type 1, type 2, type 3, like interchanging. When you interchange the row, the determinant will be the sign of the determinant of the matrix will change. If you add a matrix, the determinant will be the same. Multiply with a row with a real number 2 in a row, so it will just multiple of the determinant with the same number. So like that, the keywords are written. And if you do that, here are some example on the, please let me mute to all of you. Okay. So there are 3 questions are here for also. So you will get the idea how to approach the question.
Suppose, sir, I just had one doubt. So, suppose if it is written that determinant of 3 into a raised to transpose, so then it means that that scalar multiplier 3 has to be multiplied with all the rows, right? And all the columns.
Yeah.
It's not it's not, if we can't do it with just one, like that.
Yeah. So as the matrix multiplication rule with the scalar, it should be multiplied with the each entry, not only a single one. With a single. So yeah, here is also written the scalar when you will do the scalar multiplication with the
not rows and columns simultaneously, either rows or column, or you can say it like that, each element you should multiply the scalar with each element of the matrix.
Sir, I have a question. What is the difference?
Sir, can you take the questions who has raised the hands?
Yeah,
because
now
we are
no,
waiting
yeah.
from
So
longer time
yeah.
Randomly people are speaking.
No. See, this is just general question. Now let's back to our particular the course doubt. Now this is I want to tell all of you these things only. So solving the activity, then do the practice yourself first and then move to the graded question. This is the process. If you will do, it will be benefited to know the concept clearly. So
every question is solved with us present in the activity question, sir.
No, not necessary. Different also.
No, I saw, sir. I got
Yeah, there
question.
will be, but there are some different question also. So see there are different question in activity also. Yeah, but the thing is, if you do the solve it will give the message, but in activity it will not give the message. That is means to say feedback.
Yes, I already done activity question. Then when I move on solve with us, saw the every question in the
So if you move with
present.
doing activity, then move to solve with us, then it will be you will see that, oh, this is the exact one. But
Yes,
if you go first after the watching video lecture, if you move to first solve with us, then activity, then it will be more help. I mean, like you will get more idea. Okay. So the thing is, to do solve with assignment, you have to watch all video lecture first, then have to do solve with assignment, because solve with assignment is only one assignment and containing the all video lectures key point. So the thing is, you have to watch all the video lecture first, then go to the solve with assignment, and then one by one activity question. Or then after, you first you can repeat again, or if you are clear your doubt, just directly go to the particular activity and solve that. Like that you can do. Okay, so this is all about the course. Let's one by one, let's go with who have raised hand, like Krishna ji. You can unmute yourself and can ask your doubt.
Sir, activity question 1.4, sir.
Activity question 1.4.
In 1.4, I have
Which
four questions I have doubt there.
in question number 4?
No. 1479. I am not able.
1. Okay, 1479. Okay, the first. What is the doubt here for first one?
Sir, why it's multiplied 3 times or 2 to get the answer 8?
Sorry.
See, how I approached this, I took one random 3 by 3 matrix, which doesn't give determinant 0.
Okay.
Like 1, 2, 3, 4, 5, 6, 7, 8, 9. This one gave 0, right?
Okay, so the simplest thing is, hope you know the scalar multiplication with a matrix. See, if you multiply with a scalar to a matrix, like C times, okay, where is that? C times A, B, C, D is there. Okay, sorry. It will, let's say this is alpha C. So it will be alpha A, alpha B, alpha C, alpha C. It will not a particular. Now, if you take the determinant of it, what will be the determinant here? Alpha, it will be make one alpha here, and it will second one alpha. So this is alpha time alpha, A, B, C, D, the same. This is the determinant of. Okay.
No,
so
this point, if we take the determinant alpha, how you got, sir? Alpha square?
So it will be alpha square, the same matrix. If you say this is the matrix A.
Sir, I think what he's asking is, since alpha is common to each element, why can't we take a single alpha outside instead of?
So no. So see, so so the thing is, then what is the rule of here?
Okay, can you go back to your working board?
Okay.
So he actually column 1, from the column 1 taking alpha common, and column 2 also taking alpha common. That's why it is coming alpha square. Yeah,
actually, see, if you gone through the video lecture, sir said if T time alpha, T time A, B, T times C, D, if like this a matrix, then determinant of this matrix is T time determinant of this matrix, right? This one, not this not is the this will be like.
Can we try to solve the same, sir? 2 by 2. This is 2 by 2 matrix.
This is for 2 by 2.
Determinant of alpha A, alpha B, alpha C is alpha D is alpha A times. Okay, alpha A.
So what will you, let me write here, what will you determinant of this matrix is, it will be alpha time A, alpha B, C, alpha C, right? This is the same thing as here I did. This is the same. I took alpha out. Now again it is the matrix here where the second row multiply with the alpha. So again you can make it out alpha here. It will be A, C, B. It will be A, B, and C. It will be D here. So D here. So that's why it is alpha square, the same matrix.
Is it? No, if we have 3 by 3 matrix, so alpha A times we take the inner one.
So what's the logic basically of?
Sir, can I say something?
Anyone can, yeah.
So what happens is, like, when you multiply a matrix with a scalar, that scalar multiplies with like the product is obtained by multiplying that square with each element of the matrix. But when you
That is clear.
Take the determinant, then for every row you take out that scalar once. Every row or every column. So if there are
In this case, no, in this
three
case,
rows, that value, that scalar gets like you can take that out 3 times. So
But
alpha
what
would
is the
be
logic of
multiplied
taking
3
it
times. That would be
thrice?
alpha. If you look at the determinant,
no,
for each row you can take out the common ones.
No,
So
no,
if you
no, Sheikh, 1 minute. Sir, can you go back to the working board, sir?
See, logic is, if she is asking the logic is, see, in the video lecture, if you see that, this is the logic, right? If you such thing is happening,
No, can you
then
wait,
it will
sir?
be the determinant.
No,
exactly,
here,
sir.
Here, alpha A, if we take out alpha A, then first row and first column we will be avoiding alpha A into alpha C minus alpha B into alpha C. Correct? No, that will be the.
I don't think we are taking out alpha A. We are taking out alpha only twice.
Yeah, it was why you are doing like so. How much? Why you are?
Sir,
you
can I
confuse
say
this
something?
much?
Can I say something, sir?
Mhm.
Sir, here, if you are asking any logic or something, if you expand the determinant, you can see that alpha square you can take common, sir, from both the terms. As you said here, that is alpha A into alpha C. So alpha A into alpha C means what? Alpha square A into C minus alpha square B into D. That means what? You can take alpha square common, right? If you will take alpha square common, then it will come as AC minus BD. AC minus BD means what? Determinant of A. Determinant, right?
Yeah, correct. This is the I also think with
This
you.
is, I think, this is the correct answer.
That is the logic. And
Yes.
actually, in 3x3, 4x4, whatever determinant you take, you can
No,
take common.
Even
You can take common.
my approach was like this. So alpha squared AC minus BC. Yeah, correct. So AC minus correct. That was
Sorry, BD. I made it. SC minus BT. Here is T. So AC minus BD. Yeah. Oh no, sorry. AD minus BC. Sorry.
AD minus BD, which is nothing but determinant of ABCD. Matrix of determinant of matrix of A. Okay. Yeah. This is what I did actually. I did alpha A times alpha D minus alpha B minus alpha C. So alpha squared we can take out common. Okay, got it.
May I say something here?
That is the thing.
Yeah. Okay.
The logic behind the alpha being common, because if we want to solve here is a 2x2 matrix. If we have a 3x3 matrix, then you can solve using convention method. But calculation it a bit difficult. So that's why we use the property of determinant and.
Yeah. Correct.
And
See, each time doing this is the difficult, so use the property of this.
Okay. Sir, if you don't mind, can you list down the properties?
Yeah, so you can see that. See, there are so many doubts are pending. So you can see yourself. Yeah, check yourself and see whatever your raised doubts are. Please check this using this property and let me know.
Krishna, sir, I want to say one thing, sir. CBSE, go to CBSE website, CBSE class 12. Chapter number 4. So if you will search in Google, that book PDF is available. NCERT book PDF is available. Go to chapter number 4, 7.2 exercise. If you will see, sorry, not 7.2, 4.2 exercise. If you will go to 4.2 exercise, before the exercise, whatever examples are given, all the 6 properties are there, sir. You can check that. PDF is available.
Okay, thanks, madam.
PDF is available.
And that book is very helpful.
Yeah. NCERT book, textbook, maths textbook. If you will see, all the properties are available.
Okay, thank you.
And very nicely written, sir.
Okay, thank you, madam.
Okay, so thanks, Krishnaji. Yeah, and rest all question. Please try yourselves. Please use the property first, because the activity is mostly uses this
properties. Okay.
So let's move on to the next. Papuri Sharma.
Yes, I want to ask one question. First of all, sir, practice assignment solutions are not given. Earlier in term 1, we used to get practice assignment.
Yeah, so no. Today probably it's given to upload. Let's see that it's now maybe available. Let's see. Is that Okay, it will be available. See, it is given to the operation team. It will be today.
Okay.
till
If you
9.
will submit parallel, if you will upload parallelly, then it will be helpful for us, because it is what, sir, we have to study some other courses too. So at a time, if we will finish, so then it will be helpful. Again and again, it is, for me, I'm finding difficulty, because again, I have to open, again, I have to see. Okay, anyway, one more thing I want to ask, sir. Sir, I
Sorry,
have
PDF of
confusion
practice
regarding
assignment. Sorry,
unique
PDF of,
solution.
sorry,
Can
sorry. Let me clear it about you. PDF of practice assignment, is it, or solution of solution of practice assignment?
Solutions of practice assignments.
Okay, so actually this is at least, see, when the week started, we left for at least 3 to 4 days to yourself do. Otherwise, see, if we give the solution, if you are unable to solve, we just go to the directly to the solution. If you we didn't give you, then you will do yourself more and more and try to learn. That's why we parallelly we are not used to give. Yeah, at least 2 or 3 days we make a pending kind of thing. After that, we used to upload.
Okay, fine, sir, no problem. Next thing is that, sir, I want to know from a system of linear equations, how to find out unique solutions, no solutions, and infinitely many solutions. As in the video, lecture video, I have seen the graph, through the graph. See, when we are doing the exam, then graph, using graphs, if the coefficients are very big, then it is what, it is difficult to draw the graph. And is there any other way to find out how to find out unique solution and no solution and infinitely many
Yeah,
solutions?
actually there is
Famous rule, sir. I think that would be covered in the
second week. Yeah, it will be covered in the second week, and there is a Gauss elimination process. It will give you
Cramer's
idea.
rule, that is useful for finding the variables, right?
Exact
X,
solution
Y, Z.
for unique solution.
Yeah.
Cramer's rule is for finding unique solution.
Yeah.
But when you are in the no solution or infinitely many solution, the Gauss elimination will tell you is that system of linear equation has no solution or infinitely many solution.
Okay, so practice assignment, that question number, I have a doubt in practice assignment question number. Just a minute, sir. Question number 6. Can you explain that?
Question number 6. Okay, this one 6. This is for determinant.
Yeah, I'm asking that one. Just
Okay. For this question.
Yeah, this question I'm asking.
So again, the same just now we discussed. See, the matrix B is written that we obtain matrix B by adding 5 times of first row of A to the third row of A, and adding 10 times of the second row of A to the first row of A. So you know that this is the third type of row operation. And if you see, if you add 5 times of the first row of A in this, if
so can you use whiteboard and so?
Yeah, actually, yeah, okay. See, just a minute. See, if you do like this for any, this is the general matrix. If this is happening for this matrix, you added sorry.
So the values are determined does not change.
The thing is, if like this, A, B, C and D, if you are doing, or determinant of this matrix is exactly will be the same if you are doing like this: A plus T times C, B plus T times D, C, D. If you are doing this, the determinant of this matrix is equal to this matrix, whatever you obtained this matrix. So the B matrix is actually saying it is the 5 times to adding the, see, this is the first row. If you do this thing in any row, with the multiply with
inverse, B inverse is given.
So B inverse is given. So what is the determinant of B inverse? Determinant of B inverse is exactly 1 by determinant of B.
Reciprocal of determinant.
So use this property.
Okay, fine. Understood, sir.
Okay, so this is all about.
Sir, also finding the inverse won't be a question, right?
So finding the inverse, you will see in the next week how to find the inverse. Then Here is taught about what is the determinant exactly.
Okay, okay.
What is the relation in between?
Yeah, that is the actually I also had the doubt. Actually, inverse finding is not showing. Then here it is asking inverse. So I did not think about the determinant of B inverse. We can think.
Yeah, actually this is covered in the video lecture. Sir have explained 5 or 10 minutes about this. So that's why this question is given. That's all, nothing else. Okay, so let me move to the next. Please, everyone mute yourself. Ajay.
Sir, exactly what is inverse of a matrix?
You will see in video lecture in next week. You can see it is a different process. That is a long process, finding the minors, cofactor, and write the matrix, find the transpose of the matrix. So
We'll do it in second week.
Yeah, you will see this in second week. Yeah.
Okay, thank you.
Hello, sir. 1.1, question number 5.
1.1. Question number 5.
I got different answers, sir.
Okay. Okay.
So according to me, I got answer, option B is correct, but in the answer sheet given, answer sheet given C is correct. How, sir?
Okay. B. You got B out.
Yes, Z is 36. I got.
Yes, sir. Yes, sir.
But here, but answer sheet given
Let me
Z
mute
is
you, all of
50.
you first. There is some. Then you will be unmute yourself and ask. Okay. So now you can unmute and tell again because someone has.
Sir, I got X is 60 and Y is 53, but Z got 36. But in the answer sheet given, Z is 53. How?
In answer sheet is Z is 57. This one here is 57.
57. Okay. Yes, 57. Yes.
Okay. Is that for everyone? This is getting the.
Yeah, I also got the.
Yes, sir.
No,
I got the right answer.
No, sir. I got the right answer, sir.
It's because
Yeah, it's 57 only.
To update actually, sir, Farjana marks have been
There is a
doubled.
condition we have to do that first.
Yeah. So actually, yeah, maybe you made a mistake in
Mistake, yeah, 57.
Please check Farjana. Yeah, it is
Doubled.
Doubled. Yeah.
Yeah. So then we have to.
Okay. Okay,
sir, in this maths too, everything is particularly of CBSE 12th, or is there something related to engineering concepts also?
Yeah, see, if till week 3 you will see very similar to the till 12 you will see, but after the week 3 the different notion will come, a vector space.
So that is the engineering concepts, right?
This is the course of engineering, or you can say yeah, this is a course of engineering, or this is come to in the BSc mathematics also.
Okay.
Hello, sir. In this activity only, question number 8.
Okay. Let me go with the rest. Okay. This activity, question number 8.
Yeah.
Okay, this one.
So, sir, here I am getting this V4 thing correct. That V4 is multiple, the scalar multiple of A plus B. But sir, I don't understand that why these options like this V5 scalar multiple of B, why these options are selected as correct, right?
Multiple can be
the same doubt for me
anything.
also, sir. Multiple of 1, it is being considered, right?
Multiple can be of anything. Multiple can be 2, multiple can be 1 by 2, multiple can be 1 by 3.
Sorry?
Multiple can reduce the actual size as well.
Multiple can be integers as well as real numbers.
Yeah, fractional numbers as well. So that's why either here V5 is reduced. Multiple can be 1 by 2 as well. Multiple can be 1 by 3 as well.
Yeah.
So V5 could be like half of B.
Yeah. Okay. Yeah, but how B4 become the
B5.
multiple of A plus B? That
It is
so we
double
will
that.
get by
Double the A.
Just get it.
that we
Yeah,
can get.
magnitude of V5 is greater than I think V2 or V something. Magnitude greater than VA.
Yeah,
Then
actually, see the
resultant
No,
will
no, it's
resultant
A
will
plus
be
B.
four.
We can just calculate, right? A
No,
plus
no,
B.
no. A plus B gives the resultant.
Yeah.
A plus B is the vector addition.
Yeah.
So when you add A and B, you'll get B.
Yeah. We can get
We'll get
V4.
something similar to V4, which is which
Yeah.
would be
No. You see first that there is a different angle. There is V2 is in different angle and V5 is different angle. So we cannot add scalar type addition is not allowed. This
no
is
vector we can add. A and B are two vectors that we can add.
yeah. Okay.
So the resulting vector would be something in the direction of V4, and that V4 may be a multiple of that vector in the direction of X.
Okay. So
Yeah. So when you add A and B, you get 1, 0. When you add A and B, you get
we get 1, 0.
0.
So did you got your answer here or discussed?
Actually, sir,
yeah, that my doubt got cleared.
So actually, when you add, it will be a vector in the on the this x-axis.
Yes, I understood. So it
It's a
will
multiple of.
Why
So
on the
basically
x-axis?
this-
Why not V3 is on V3 vector multiple of it?
So why
Same
V3 is needed to be a coordinate, non-zero coordinate, because see it is the like here. If you coordinate, suppose this coordinate is see V3 is not like lying on this line or this line. If it is lying in this line,
1, or 2,
it will. If, suppose it is lying this line, it will be like this. Alpha time A.
So y should be
Alpha
0.
and 0. Alpha and 0. If it is lying on y-axis, it will be like 0 and B.
Yeah, okay, sir.
And vectors are added component wise.
And the vectors are added component wise. Sorry, component wise.
That.
So basically,
I
sir,
didn't check
in this kind of situations, we'll just add them and see that whether, like here, what I did is A plus B, it came 1, 0. So I just searched that, okay, V4 matches 1, 0, may match 1, 0. So V4 can be that. So is that the right approach, or there should be any other approach?
Yeah, actually, but the need to be understand the concept. Yeah, okay, V4 can be that. Yeah, see, but V4 is not given exact what is the coordinate of V4. Yeah, it can be. Yeah, so it is written like it can be. So that's the here written.
It can be. Yeah.
Okay. So let's move to the next.
Okay, sir.
Samadhi?
Yeah. Yes, activity 2, question number 7, please, sir.
So can I ask one doubt?
I have also doubts, sir.
Let me go with the who have raised. Please raise your hand. That will be more better.
Yeah, sir. You called my name.
Yeah.
So, which question number?
Question number 7, activity 1.2.
Sir, can I ask my doubt? You called my name.
Ajay. No,
Yes, sir.
You called
have
Somodhi.
cleared your doubt. You can remove your raised hand. That will be.
I have also doubt, or I have. That's why
Okay. So
my raise.
See, the thing is, if you got cleared, okay. The second time you got doubt, so later, see, that's why that's the thing. You will raise your hand.
Okay, sir.
One by one, so that everyone I can raise to everyone. Okay.
Okay.
So
question number 7.
7. Okay.
Yeah.
So what's the doubt here first?
It's totally confusing. I cannot even proceed with it.
C2.
Yeah.
See, C1 is the first column of the matrix A and C2 the second column. So, and B is matrix this. Then the first column of AB is this. The second column of this. The third column is like. So, how did you try this? Like, how did you try this?
So actually, what I thought was first we have to go with a row of A and then with the column of B. But here in A, we just have the column. How to proceed?
Okay. Anyone can?
I am facing same doubt, sir.
Okay.
Same issue.
if anyone got how to approach will be better, maybe more convincing, maybe more better than me. Like
Sir, I have a solution for that.
Okay. You can tell.
What we can do is
I can try.
Yeah.
Let him finish. Okay, continue.
Okay. So, sir, what I was saying is we can consider metrics of 2 by 2 order, like A is equals to A11, A12, and A21, A22. Okay. In which we can not suppose, but as the question is mentioning, the first column we can call it as C1, and the second column we can call it as C2, right? So we can multiply, like we can calculate AB, and then what will happen is we will be getting A11, B11 plus A12, and B21. Right.
Actually,
And
yeah,
then,
this is the correct way. Yeah, let me now finish. Actually, I was also going to the same way as you are doing. Just
Okay.
assume that the matrix is A11, A12, A21, and A2. If it is not written, so you can assume this is C1, this is C2. Now multiply.
So we can assume like this, okay? Then
and then do the arrangement. After multiplying, do the arrangement.
Okay, then.
So can you
Everyone.
explain the next question also, the eighth one?
Okay, so everyone got this idea. I listened 2 or 3% have the doubt. So the thing is,
So
just
sir,
we
if
did
it is
so.
not given like A1, A12 like this, we can assume and then proceed. Like
see, many times if you have difficulty, like matrix is not given, take a general matrix assuming that these entries A11, A12, or maybe A, B, C itself. How
okay. And after doing all the calculations, just replace it with C2 and C1.
So do the whatever the thing is saying, do according with, and take whatever the results are coming out.
Okay.
Or other than that, we can simply use C1 and C2 also.
Yeah, otherwise you
C1
can
and C2.
simply do C1 and C2.
Yeah, I did
very
that
much
too.
clear with the definition of multiplication of the matrix. If you are very much clear how it is, how we are multiplying C1, C2, multiply with this matrix B11. So if you are very much clear, you can go. Otherwise, you can assume.
Thanks.
So can I ask my doubt?
Okay, let me go with the next one. Then see one by
You
one.
called my name previously.
Okay.
So
okay, you can.
So 1.3 question number 9.
1.3 question number 9. Okay.
Yeah. Like what determines it? Like the k value.
So in this question, see how you are approaching. My question is how you are approaching to solve.
Like yeah, so like my approach would be like the slope of these two lines cannot be same. Is that correct? Like
the slope, saying to be unique solution.
The
so
slope
that means
has
the
to be
slope
same,
should
sir.
be not the same if you are relating
They
with the
intersect
quadrant.
only at one point.
Sir, I think the best method would be to find the determinant, and that should not be equal to 0.
That's also if you know the it is thought to be if determinant or not 0, then matrix have unique solution. Is that the video lecture?
Yes, sir.
No, determinant didn't come only. No, determinant is the next.
It will come to the next, so no need to use that also.
Yeah, so now that is
So
not
the other thing that we can use, sir, is that the second equation should not be a multiple of the first.
Yes.
Second equation should be equal to first equation. Then the k value is.
And then we can solve.
Yeah, if you multiply, it's like a parallel line equation you should get.
Yeah, actually, see, whatever the line the first equation represents, suppose this line, whatever the line, no need to be go to the exact. Suppose this line represents the first equation represented by this line, and saying to be unique line, what it means that the second line will be surely intersect.
Intersects only at one point.
At one point only, and
So
two
then
lines
we
will
can
intersect.
equate and get the solution of K.
So what it means that suppose this is the equation by is equal to d. So in this case, if you are relating with the slope, or see the other things are for infinite solution there will be single line.
Single line, yeah.
And for no solution, like this will be.
Yeah.
So this says that slopes are equal, like this will happen if you are connecting with the coordinate. Otherwise this case will happen. So in this case, with the no solution, and this is infinitely many solution, but the thing is given to unique solution. So suppose this one is that if this case is happen, then it will be alpha time ax plus alpha by, like this it will happen alpha time t. For this case, for infinitely many solution, it will be the multiple of this equation. And for this one, it will be like this: ax plus by is equal to some c, not the d. For this case, right? It will happen like this. No, this case will happen surely. C will be not equal to d. Then this case will arise. Otherwise, no. Getting?
Yes, sir. So for this case, so we just have to equate both the straight
Both the
lines.
equations, yes.
Can you quickly?
No, so saying to be not should be, it should be unique solution. What is the question?
Yeah, it should have been.
Also, can you
It should not
explain
be
the
equal
three
to.
cases, like once how to solve exactly?
Okay. So it's saying that k should not equal to.
Yeah.
What is the possibility?
It should be not equal to. Yeah.
So for if you assume like here, let me write here. Okay. So x1 3x2 is equal to.
So x minus 3x2 is equal to 4.
Minus 3x2 is equal to 4, and second one is
3x1.
See, it's simple. I think at k equal to something, this line would be
Minus
unique.
12.
Same equation.
Minus 12. Yeah.
So see, the thing you can see these two are different. So you can this can be this case, because see these two are different. Or just 1 minute, the case is here. You can do like divide this equation with 3. x1 plus k by 3 x2 is equal to minus 4.
Okay.
This is happening. This will make you to easier like comparing. So now you can relate with this one. When what is happening here, if it is the multiple, then this case will happen. If you are intersecting, you can if this case is happening, then see these are if you are assuming this one, so these two are different. It says it should be these two are different means, just 1 minute, I am unable to say clearly. Just 1 minute. Ax plus by is equal to c, and the ax plus by is equal to d. For this case, this will happen if this is happening.
Oh, okay. Like
no solution, no?
For no solution.
Like infinite solution is not possible in this case.
Infinite solution is not possible in this case because these two are different. You are divided with the 3 also, and when you divided, these two are different. So that means for this system, infinite solution is not possible.
Yeah. So the question only to show that it will have a unique solution.
Unique solution. So what it means that this should not equal to this exact one, this one. Then it will be right. Then it will be have unique solution. If it is suppose this is equal to this one, suppose I'm saying this should be, if suppose this one is equal to this one, okay,
then it will have no solution.
It is equal to minus 3 is by k is equal to minus 9.
So can you please repeat this part? What you said just now?
Sorry,
what you said just now, can you please repeat?
So what I am saying, see, we want saying to be this system has unique solution. So we have to go back when the system has no solution and infinitely many solution. Okay. So if this case is happening, let me erase all. Okay. So the simple thing is just divide the second equation with 3. Okay, when you divided, you got this one. For infinitely many solutions, what it means that the second equation will be exactly the same or maybe multiple of that, right? Multiple of the first one. But this is not case happening because here is 4 and this is -4. Okay, now we want no solution. Now need to check for no solution. For no solution, what will happen? These two should be equal, left side should be equal and right side will be different. This will happen. And for unique solution, anything can happen. So it says it have unique solution. So it means these two should not equal, then it will have unique solution. Now, suppose these two are the same and these two are the different, then it will say have no solution. That means says this k/3 not equal to.
But sir, -9 is only the answer.
-3. I think I am not explaining more precisely.
Okay, I got it.
Just 1 minute. Just
Sir, we can directly use coefficient also.
Let me
Sir,
try.
sir, can I try? Sir, can I try?
You can. If you have a better idea, you can.
Okay.
So -9 is only the answer.
Okay, so visualize a line in XY plane, any line. Okay.
Hmm.
So how many line can it be possible which can intersect that line?
That is also, yeah.
So guys, I'm asking you,
okay.
how many lines is there possible to intersect another line?
Infinitely many.
Okay, infinitely many lines. So if I ask how many lines, you said that infinite. So there can be infinite k also. I mean, there can be infinite equations which you can make of every line which can intersect the given line. Okay. Now here the question is, it is asking that tell me the k for which it should not have that unique solution. So a line has a unique solution only if the equation of line is same. So you have to check that for both equations, you have to check that equation is same. Put that k for that equation 1 and equation 2 same, would be same. And that k should not be equal to, that k should give you unique solution. Okay. And the question is asking to not to give unique solution, I think maybe.
No. Actually, if both the equation is same, then the multiple solution.
Infinite number of solutions. Then there are infinite number of solutions.
So I mean no that is what I am saying. No unique solution.
No unique solution.
No, that is what I am saying. No unique solution means infinitely many solutions. I was just explaining the language of the question.
No, sir. No unique solution means maybe infinite many solution, mean no solution at all.
Or parallel. That's all.
Parallel.
Yeah.
Two lines will be
Infinitely many solutions, or it is parallel. There is two possibilities.
We can directly use coefficient also.
Coefficient also.
Like two equations are given, then if a1 y a2 is not equal to b1 y b2, why that?
So that is not taught. See, here is taught in the only with the diagram. Okay. So the thing is, let me again explain. Maybe I will slowly explain, then you will get. Let me.
So use diagram, then it will be easy.
I will use the diagram.
Yes.
So suppose this is this equation represent this line. Now I have second equation x1 minus k time x plus k
Plus
time
k.
is equal to -12 something. Yeah, -12. So suppose this equation represent this line and says this system. The question says if the given system has a unique solution. So it already said this system has unique solution. So what we know, this line represented like this, it will surely intersect, then it will have unique solution.
Perfect.
Okay. Now back to the our cases. If suppose this line represent, so this first equation represent this line, and second, if suppose the system has infinitely many solution, the second equation represent the same line. Perfect. Right? But our case is different. So we want unique solution. We want unique solution. This okay. Now this come to the second equation. come to the next one. If suppose the first equation is represented by this line, and the third one is, if anyhow I will try, it will intersect, the remain thing is it will be like this, parallel to this one. In this case, the system has no solution. The only thing is, so what it mean that, now back to this one, this is the case when suppose this line is ax plus by is equal to c, and it will be like this, ax plus by is equal to d. For this case only these two equation will happen. But our question is, then k should not equal to, we want unique solution. Suppose k equal to suppose
Sir,
k,
this is not our problem only, no. This has infinitely many solutions. Sorry, no solutions.
No solution.
Our diagram should be the first one, right? Which intersects where both the lines intersect at one point.
Should I speak, sir? Yes, system has a unique solution. Question is unique solution. For unique solution, the coefficient matrix should be none, means determinant of the coefficient matrix should not be 0. Means k minus k plus 9 should not be 0. Then only unique solution will exist. Means k should not be equal to minus 9. That's all.
that is one thing. That is, see, we are trying to deal with the diagram only. Otherwise, see, we have already this determinant kind of thing, but we are trying to deal with the this diagram. Otherwise, we have algebraic kind of thing.
So can I just give a shot on this?
Yeah, sure.
Yeah, so we have two equations out here, the x1 minus 3x2 equals 4 and 3x1 plus kx2 equals minus 12. If we divide the second equation by 3, you are getting a minus 4, which says that by changing k, you cannot get a parallel line, because the only way by changing k you can get a parallel line is if minus, instead of minus 12 you get 4. So that is not a possibility. By changing k, you cannot move the unique solution to a many solution. So that option is not available. But we can make it into a no solution by changing k. And how that's possible is that the slope of you cannot have a no solution because 4 and minus 4 is there. But you can have a parallel solution if the slope of the first line and the second line is same. That means minus 3 is equal to k by 3. That's so if you change k in such a way that the slope is same, then infinite solutions can come. And that's why I say if k becomes minus 9, then you have infinite solution. I think that's my understanding.
Excuse me, instead of dividing by 3, what if I divide by minus 3?
You can if you divide by minus 3, then you can't do x1 and x1 will become minus 1, right?
Oh, right? Yeah, sorry.
Yeah, you can also. Yeah.
Sir, could I speak?
Yeah.
The question is the unique solution. Unique solution will exist in the line.
No unique solution. No unique solution.
Okay, no unique solution means line should be parallel. Line should be parallel.
No, like it should have, but if it is parallel, then it won't have any solution. That is not the case here.
That's the point.
Yeah, that's the point. That's the if it is
It
parallel,
has to have one solution for sure.
So we want
we'll go for many solutions, right?
So see, we want such k so that it have no, say, then k should not equal to like that. The question is like asking differently. Then k should not equal. If k should, suppose k equal to, suppose this system has unique solution, then okay, this system has unique solution. What it mean that it should be, okay, just one. This system has unique solution means intersecting.
Yes, sir. The first diagram intersecting only at one point.
Yes.
Intersecting at one point.
May I explain?
You cannot have parallel.
Suppose my thing is, suppose the thing is, suppose your k by 3 equal to minus 3. Suppose I am saying, just suppose k by 3 is equal to minus 3. what will happen then? It will be k is equal to -9, right?
This is only the answer.
Okay, it is. I'm not saying. Suppose k is equal to -3, so it will be -9. So let's substitute here in the second equation. X1 minus 9 by 3, x2 is equal to -4. This implies x1 minus 3, x2 is equal to -4. Now compare this one with this equation.
No solution exists there.
No solution exists there. This says, right? This solution exists here. So what need to avoid then? Then k should not equal to -9. That's the thing.
Okay.
Are you getting?
Yeah. Because for -9 there would be no solution.
If k is equal to -9, then no solution.
In any other cases, there would be at least one solution.
At least one solution. That's how you want.
Sir, but here it's given unique, right? You have to have only one. We can't have multiple. So how to ensure that?
Sir, may I try, please?
No. Sorry. I didn't. Just 1 minute. I didn't got your
Sir, see, now we are saying that here it needs to have a unique solution. So, like no solution. Okay, that's fine. I mean, k equal to -9 means no solution. But in that case, we can't have multiple solutions. We
Actually,
just need
it is
to
not
have one.
happening. See, for infinite solution, this case is not arising. You can see because this is 4 and this is -4. This should be multiple of the first one, then it's having infinitely many solution, right? The problem is only here, but right side makes clear that this system has either no solution or unique solution. The right side of this one, what says? Either no solution or unique solution. If it is infinitely many solution, then these two should be equal.
So how does the right hand side determine it? Like how is it?
Actually, because of this case will happen. Suppose we have a system of equation like this: ax plus by is equal to c, and the second equation, suppose and you are writing let's say a prime x plus b prime y is equal to c prime, and you are saying this system has infinitely many solution. What it mean that the second equation should be multiple of that, then it will represent a single line, right? Otherwise it will not represent the single line. If the second equation will be not the multiple of the first one, it will represent different line. It will represent different. Are getting? No.
Sir, may I try to answer this?
You can. Okay.
I'm sorry, I didn't get who was asking.
Sorry.
It's as simple as this. There are only three possibilities. One, you can have a unique solution where the lines are intersecting. Two, you have overlapping lines. So there are infinitely many solutions because they'll be intersecting at every point.
Correct.
And the third is there is no solution because the lines are parallel and they will not intersect. So there can be no solution. If we look at it from a graphical point of view, we would understand. But from an equation point of view, there can be only infinite many solutions, as Sir is trying to say, when one equation can be a multiple of the other. So for example, ax plus by is equal to c, and the second equation is 3ax plus 3by is equal to 3c. It has to be an exact multiple from left hand side and right hand side both. But if we look at these two equations in this particular question, one equation, the first equation is the second equation is definitely not a multiple of the first one, because if it was, then this 4 and -12 would be, they would have the same multiple.
Yeah.
That is not happening in this case. So infinite many solutions is just ruled out in this particular case. The only thing is it can either have a unique solution or it can have no solution. So we don't want a no solution case, and that is what we're trying to rule out.
Yes.
Yeah, this is the point is there in the question also. Only unique solution or else no solution.
Getting no, that is I want to say.
Mentioned in that question.
Yes, got it, sir.
Sir, the right hand side is basically the intercept part, right?
Right side is the intercept of that is.
So in that way we can also think, right? Because for the parallel lines, the slope part is same, but the intercept is changing. So in that way, it will be easier to remember, right?
Yeah. You can also. Okay.
So practice assignments are question number 3.
Okay, so Oh, you are asking. Your doubt is finished, or you are?
No, sir. They are
practice assignment.
Practice assignment. Yeah. Question number 3, option A.
Question number 3. Okay. Option A.
Yeah. So my doubt is, sir, the option 1 is actually correct. But sir, the problem is if I have a matrix in which they are all one or all one. Suppose there 3 into 3 matrix and all the element of this is 1. Then we will get determinant 0. But
no,
according
then if the diagonal is 1, then it is an identity matrix, sir, and determinant of identity is 1.
So for no, it's not identity matrix. All element is 1.
Okay, all element is 1. Yeah. So determinant is 0.
Determinant is, but according to the statement, if the determinant is non-zero, diagonal entries, okay, diagonal entries are non-zero, then determinant should be non-zero.
Diagonal, not all. Diagonal only. Talking about
only diagonal. So, is that right or something?
It is said that it's a triangular matrix.
It is a triangular matrix. So I also confused.
It's a triangle.
About the first. I also
triangular matrix.
Okay, you said so. I started thinking how this option is triangle. Talking about the triangular, maybe lower or upper.
Okay. Then, so can you state it on the whiteboard?
Actually saying to be this matrix is an upper or lower, any triangular matrix. Let's assume this is an upper triangular matrix. Let's say A, B, C, D. Sorry, this is 0, D, 0, 0, F. And determinant of any triangular matrix is exactly the multiplication of the diagonal.
Okay. So my mistake was just I thought that it was the whole matrix.
For general matrix. So I also assumed, I also.
Okay, sir. I just got the. Thank you, sir.
Okay.
Sir, in this, could you also explain option number 2?
Let's go with the I will back. Because many of have raised hands. So let me go.
No, in the same question, the option number 2, if you could explain.
Option number 2. So option number 2 you can neglect with the giving an example, like give a particular matrix, 2 matrices.
It's true, I think.
And do evaluate the determinant, and are you able to see that both are equal or different?
So without taking an example, it's not possible.
Then how you will guess that?
Okay.
No, sir. As there was a concept, we can add a matrix with the same dimension, right? So A and B as A and B are having 3 by 3 A and B are 3 by 3 matrices, so they will add up to that, and it is similar to A plus B, right? So determinant of A plus B also will be equal to determinant of A and determinant of B. Some of them.
No, actually, see, if you know the evaluation process of determinant of a matrix, you will know that what's happening here. Like for 2 cross 2 matrix, you can check with the exactly giving a simple any matrix, diagonal matrix. You can check using the diagonal matrix. You can neglect with also.
Like identity matrix or something like that.
Diagonal or maybe scalar, not scalar. If you check with the scalar, it will give the same answer. If you check with the diagonal, it will give the these 2 matrices have different. Like so, give a particular. This question can be negative with the giving a example can be.
Okay, sure, sir.
Okay, so now.
Okay, sir. One more question, sir. Question number 10 of practice assignment.
Oh yeah, I will be back now. I will be back. First, let me.
Sir, 1.3 question number 7 and 1.4 question number 8.
1.2 question.
1.3, sir.
1.3 question number 8.
7.
8. So 8.
7.
7. Okay. Okay. So what's the doubt here first?
Sir, I don't know how to approach this question. If x1, x2 are the solution, then how should I approach? Because ax is equal to b is the matrix. A is the matrix, x is the variable, and b is the constant.
So see, the thing is, see how you can do that. anyone can tell also if you got idea how to, and if someone will tell, then will be more. Otherwise, let me tell. Okay, see, saying to be x1 is a solution of ax equal to b, x1 and x2 both. What it mean that? First, take the meaning of that. X1 is solution of ax plus b. It means ax1 equal to b, right? This is the meaning. Okay. Saying to be solution. Similarly, x2 is also a solution of the system ax plus b. What it mean that? This will be ax2 is equal to b.
Sir, but I have one small doubt here. So system means all the equations taken together or one single equation taken at a time?
Let me mute to all of you first. There are some. Then you can unmute yourself and again. Yeah, you can unmute yourself.
Sir, I want to ask, sir. In a system of equations, we take all the equations at a time, right? This is the system of equations.
Actually, see, any system of linear equation can be converted to kind of ax plus b, where x is actually the x1, x2 kind of thing. Let's say this is still only x2, right? And a is actually the coefficient of this entries of a is the coefficient of and a, b, c, d. Let's say this is. And b is actually right side. We have the system of equation like this: ax plus a bx2 is equal to, let's say, alpha, cx1 plus dx2 is equal to beta. So what will the matrix representation of this system of linear equation? It is a will be a, b, c, d, and x will be x1, x2, and b
equal to alpha and beta.
This is the
right.
Okay. Now see, here x1, x2 are the entries, but here in the question x1 says this should be like a matrix kind of, right? This is the main. You may confuse because of that. Yes, actually, see, x1 is actually because of that. Okay, here x is actually says to be, let's say, like this. This one. Let's say what I will give the variable name. Let's say y1, y2.
Yes, okay.
And x1 is a solution, so it will be like a particular thing. Let's say x1 is it will be like this. Let's say z1, z2. And x2 is different. It will be like this matrix. See, x1 is this one. See, this is the x. It retain x in the form of this column matrix. Here x1 saying to be the solution of ax is equal to b, means ax1 is equal to b, where ax here x1 is the column matrix. This is the mean, not this entries, no, not these entries. Sorry, here this one, these entries. So be clear with that. It will be saying to be solution means it will be a column matrix.
Right.
So you can compare. So solution means saying to be it will be like this. This one ax1, ax2 will give the right side b or b, because both are solution b.
Then when we will add,
then you can see add, if you add this two, or maybe like this. You can do like see, we have this equation. Now what are the options? x1 and x2 is also solution of this one, saying to be, let's say, first option. So what it means then? Let's check a saying to be x1 plus x2 is also solution. It will be like this. Let's check it's giving b or not, right side of the matrix or not. So what it means that it will multiply ax1 plus ax2. And this one says from here it is b. And this says from here it is also b. So this is equal to, actually this is equal to this, and this is equal to this, and this is equal to 2b. So is that happening for this case? No, this will not be. It will be this one.
This is happening.
I did not get this one clear.
So like this is the maybe many of you confuse the x1, the coordinates. Sorry, x1, x2.
Yes,
so actually
sir.
this says not this one, not this one. Sorry, this one. This is the solutions. This
solution is a column matrix.
Columns are saying, not the entries of a particular. Okay.
Sir, I am still not very clear on the question.
So let me, Naveen, you can remove your hand and let me go with the next. Divya.
Okay.
This hand, raised hand. Divya, you can. Okay, Divya is also done.
Hello. Sorry, I couldn't unmute.
Okay.
My question is on this only. I didn't also understand the the second part of it also, the option 4 also.
This the same question. This option 4.
Yeah, I didn't understand.
Okay, so again the same thing. X1 minus x2 is the solution of not. Let's do again as here, the same as we are doing. Let's check x1 minus x2. Is that giving?
Sir, can you please close the left part on this OneNote, because
yeah, okay. Yeah, actually, then it will be for me again. Okay. I have closed. Okay, so if suppose saying to be ax plus b, so saying what it says, x1 minus 2 is solution of this one or not. So let's check that. Let's take the right side of this one, this system, or this matrix form of kind of the system only. Take right side. Okay, now says here x is actually x1 minus x2. That's the meaning saying here, because x is a variable and particular value is x1 minus x2. So let's check here. Take right side and apply here. It is equal to ax1 minus ax2. Now this give b. This also gives b, as here we have. So what is this? This is b minus b. This is equal to 0. So we got right side of this. See, here is dealing a matrix kind of thing. Actually, you are dealing with a simple normal equation. That's the main.
So we just have to substitute, right?
So in a way, we could say, like, if supposing the system of equations has
as a normal
variables
equation,
x and y, if they have variables x and y, so x1 would be one value of x and y, and x2 would be another value of x and also of y. This is what it means, x1 and x2.
No.
So, for example, in the first case, x1 would be having an x of 2 and y of 5. And x2 would be having an x of 3 and maybe a y of 7. So, this is what x1 and x2 means.
Yeah, actually, x1 will be a column. It will be a particular value of x. Okay,
so if I take the variables, supposing not x and y, but m and n, if the system of equations has two variables m and n, so x1 will represent one value of m and n, and x2 would represent another value of m and n.
Correct. Yeah.
But why would there be two solutions having the same right hand side? How would that be?
Yeah, it can be. See, it is not saying anything about this system has no solution. Saying to be x1 is a solution, x2 is a solution. So it may have like it may have the system. See, we can change the system by adding two equations like that. We can do. No. I think
or multiplying maybe.
No, not multiplying. See, as you said, x1 is kind of, x1 will be m and n, x2 will be different, m prime n prime. This is the mean. Now this is x1 is we have already, x1 is a system of this solution ax plus b, and here your x and y, you can say this x is actually, this is maybe, let's say,
actually I was taking the variables, that is your ax, the x part to be m and n. I was taking that to be m and n, and I was imagining an answer, a solution x1 where m's value is one thing, and then maybe m has a value of 2 and n has a value of say 5. That's what I was imagining. So
yeah, actually that
m and n were my x in ax.
And actually that is the mean also. So what I am saying, if you suppose this is written, so you can assume like this is a simple equation in this in real line, like you know that x plus 3 is equal to 5 or not. somebody says x is equal to 3 is the solution, then let's say somebody says x is equal to 3 is a solution of or not of this equation. So what you used to do, you will take the right side 3, which is x plus 3, and you substitute value here 3 plus 3 is equal to 6. So this is not equal to right side of that. Used to check like this, used to check in the simple equation. The same thing is here. The same thing is here. X1 is says that solution of this, x2 says the solution of this. So what it mean that the next one is saying x1 minus x2 is the solution of that system. Ax is equal to 0 or not. X1 option is x1 minus x2 is the solution of Ax is equal to 0 or not. So how you will check? You will take the right side of it. So let's take rights of it, and says this is a solution of this one, means x1 sorry x is equal to some x1 minus x2. These are actually the column matrix in this form. In these form these are. So now substitute it here, it will be a x1 minus x2. You are applying the same thing as here you are doing. You are substituting value and checking that we are getting right side or not. So this is equal to ax1 minus ax2. As you see, you are free with applying as according to the in the matrix you can do the operation. As here is there is no worry. You are multiplying a matrix with a column. You are multiplying a matrix with a column matrix. This is happening only. Okay.
Sir, I have a doubt. So not in this question. I have a separate doubt.
Okay. So okay, then let me finish it. So it means that this is actually given whatever the information we have previous one. This is equal to b and this is equal to b. So we got right side. Oh, then yeah, this option should be correct because we are getting the right side. That's the mean only. Is it?
Yeah, thank you, sir. I got it.
Okay, so let me move to the next participant. Chandauti.
Can I ask?
Chandauti, the next one is. Let me finish.
Okay. Yes, sir. Sir. Sir, activity question 1.3, question number 3, sir. This is question number 3.
This one.
Yes, sir. Yes. I have doubt in sir option number 3.
Option number 3.
Yeah. Okay, sir. If x is equal to b, is a system of linear equation.
Has a solution.
Then which has a solution? Then system of linear equation C multiply a into x is equal to b.
Also has a solution. Saying to be also has a solution or not. So what it mean that? Let's check that. Let's check this one. Ax equal to b, saying to be has a solution. What it means? What it mean that? Let's say let's operate with the 2 cross 2 or maybe in x1 x2 kind of system. So it says it have a solution. It means it will be a like it have a column. X is actually, let's say, y1 and y2 kind of thing. This is system is actually, I mean to say, it is suppose y1 plus b y2 is equal to, let's say, b1. Maybe because of b, let me take different. B1. Okay, no, b, not b1. Let's say alpha and beta, and alpha prime y1 plus beta prime y2 is equal to b2. So suppose this represent this system of line. As a general case, you can assume. So actually A is here alpha prime, beta and beta prime, and x is actually your here y1 y2, and b is your b1 b2. This is the mean of this system, saying to be generally this one actually the mean in the two variable case x y1. This is the mean of that. Okay, till here it is clear?
Yes, sir. Sure.
Okay.
Yes, sir.
Okay, so now it says this system has unique solution. What it mean that there is a value of y1 is equal to m, y1 is equal to m and y2 is equal to n, and this is happening. This is the mean saying to be solution, means m and n equal to b. When you are multiplying this with m and you are getting this b, b1, b2. This is the mean saying to be a solution, right? Means
Yes,
y1
sir.
have m and suppose some particular real number r. These are the real number. Okay. So this is the mean. Now let's back to the our option. This much information is given us. Where is that? This much information is given us. Then the system of linear, this one c time ax will also have solution. So let's check this one. Let's write the system the same as here we have c time ax equal to b. What it means is it will be c time, let's back to this one, alpha y1 plus c time beta y2 equal to b1, c time alpha prime y1 plus c time beta prime 2. This will say this, right? If you multiply with this c, no? C time A, C time A means C time alpha, C time beta, C time beta alpha prime, C time beta prime.
Beta prime.
So you will back to from this to this one, right? Okay. So we have information. We have value y1. Y1 is equal to m and y2 is equal to n. Have some value. This is the mean saying to be. So is that happening? So actually, see, you can take common C, or maybe let's see. Let me back to the option. So this system has also a solution. So let's back to our. So this one. So see, you can divide C with this one, the first equation. What will that? Alpha y1 plus beta y2 is equal to b1 by c, right? b1 by c. Similarly here, alpha prime y1 plus c beta prime y2 is equal to b2 by c. This one we will get. So if you back to the our this system, right, let's write to in system of linear equation. What will be that? Then it will be alpha beta alpha prime beta prime equal to y1 y2. This is equal to b1 by c, b2 by c. What it means that 1 by c b1 b2, right? This we will get. Actually, this is the main simply saying to be directly you can multiply like this. This is happening. You can now easily do, and we got like this. Applying like this, we got the same thing. Okay. So this system has solution means what? Just 1 minute. Just 1 minute. Okay, this much we got. Okay. We'll also have a solution.
So can I ask next? Sir, I have a doubt in question number 4 of the same activity question. I mean, activity.
Okay. Yeah, I will be back. I will be back. Okay, so
means sir, it is saying that if we multiply any real value, it follows same system of linear.
Same system. Yeah, actually, I want to. Yeah, see, this is true statement. I want to more convincing way. That's why I stuck here only. How I will explain you more precisely. That's why I am thinking next step. What I should write, then it will be. You will get that. Okay, so what is here? Okay, we got we have solution says y1 y2 is equal to this. Okay, so we got this one. So we have right said this. If I will explain with the diagram. This is y1, y2. This is means b by c. Asking for a solution only. Okay, more writing to with the diagram. If I will explain the diagram. See, by this way I stuck because saying to be a solution is by this way is I'm thinking maybe difficult. Okay, we multiplied here. Okay. Using the diagram, I will. Okay. Let's say with the diagram, maybe this is not. Yeah, actually for this you need you need to know Gauss elimination. That's why. Okay, this way is not fruitful going with this way. But I hope you got the what is happening with writing this one is how to
Yes, sir.
the matrix.
Yes, sir. Yes, sir.
Okay, so let's go with the diagram because still here we only do with the diagram. There is nothing else. I thought, yeah, see, this can be inferred with the when you go with the Gauss elimination, you will directly say, yeah, this system is also unique solution. Oh, sorry, solution only. So let's go with the diagram. It will be more precise because till now week 1 is only dealing with the diagram. So what is, see, you can assume because here is not restricted any x how many how many variables. You can assume with the x1 and x2 only. It actually work. So you can assume, suppose saying to be this system has a solution. What it mean that it will be either like this. If you assume this one is this is our system is this one only this our system is this one in two variable y1 and y2. So the first equation represent a line. The second equation what will it says this system has a solution. What it means that both equation will either intersect or it will be like this, the same line. It's this system has infinitely many solution or no solution, right? This is only these two cases only possible, not the third one, because says to be has a solution. So either these two equation will intersect or will represent the same line, the same line. Okay. Now we have c time ax is equal to b. What it means, if you go with the writing to be this matrix, c time a means this. This is these are the entries. So if you deal with the first video lecture saying this is a vector, this is a vector. What it means that whatever the vectors are lying in this one, it will just reduces or expand it. See if you see is normal integer, if you multiply, the lines will be just shifted to somewhere. Scaling kind of. It will be scaling, right? The second, similarly, the second will be just scale. So what it means that it will, if the case is intersecting, it will intersect, right? If you multiply with the c time.
Yes, sir.
It will surely, otherwise if this case is happening, so this infinitely many solution, still it will be represent the same line or maybe somewhere just only shifted because both lines are represented. It will scale to up and down only. Still it have a in this case also it system has infinitely many solutions. Is it clear? No.
Yes, sir. Yes, sir. Yes, sir.
So yeah, I am multiplying with that, just scaling up and down. But if unique solution case is there, still both line will intersect. If infinitely many solution, the lines will only up and down the case will happen. But in both cases have solution. So you can do with this one. Otherwise, when you come to with the Gauss elimination, you can also directly jump to here. Yeah, that's why I was going with this one. Maybe I thought I will explain, but it will stuck. So with the figure got clear, right? What's happening?
Yes.
So this is the mean. See, if you are not able to do the questions or these things is happening, don't worry with that. It will be not
Okay,
tough.
sir.
Okay, so if you are getting the little bit idea, that's the thing. If you half of the activity, if you are able to do, the thing is you are understanding the concept. Yeah, these some questions are like these are the theoretical questions. So if suppose there are some theoretical question, when you deal with the whole system of linear like week 1, 2, and 3, if you did, then you will maybe then you back if you solve that back to the question and solve, then you can easily solve. This is the thing. Otherwise, don't worry with that. These questions are saying to be yeah, you can connect with the this lines or you can go with this one. But this concept are using the scaling kind of thing. So don't worry.
Yes.
Okay, Virat, you can ask your doubt. Virat, am I audible? Virat, are you here? Are you able to hear me? Okay.
So I had a doubt in the next.
Okay, you can ask. What is doubt there?
Question number 4 of the same activity.
Question number 4 of the same activity. This one.
Yeah.
Okay.
So please explain this. Like I didn't understand what is written in the hint. Like what exactly does it mean? If you can show it graphically, I mean.
So yeah, actually, let me explain the hint also. The question is the plane 1 and plane 2 shown in figure in two different correspond to two different equations which form a system of linear equation. Hint says if a system of linear equation has a solution, then the point corresponding to the solution must lie on each plane corresponding to each linear equation in the given system. Okay. See, when you sir have told about the system of linear equation in n variable also, but geometrically till defined only in the 2 in R2 only, in the plane xy only. The plane, when you come to in the plane, what it mean, then you have in equations will be in 3 variable x2, x1, x2 and x3. And the case is in 2 variable, if lines are intersecting, then has a unique solution. If lines are represent the same line, then the case is for infinitely many solution. If lines are parallel, then the system has no solution. Okay, so the picture is like this is given. If you connect with this one, these two planes are intersecting each other or not, till whatever you are able to see. These are intersecting?
No, sir, they are parallel.
No, sir, they are not intersecting.
They are not intersecting. They are parallel. So if suppose a line in this plane, so what I mean, if the lines are, the plane is the collection of line, if you will say. So if lines are there, so if the lines represent that equation, they will intersect? No, they will never intersect. So if the case is this plane represent a equation, let's say ax1 plus b y1 plus sorry, the case is this plane represent an equation, system of linear equation ax plus by plus cz is equal to 0. And the second equation is a prime x plus b prime y plus c prime z is equal to, let's say this is d and this is d prime. So these two planes, suppose this plane represent this line and sorry, this plane represent this equation, this plane represent this equation. And these two planes are not intersecting, as the same case here is happening. If lines are, if you connect with the line, if the plane contain the line, in that case, system has no solution. The same thing is happening the same. These two planes are not intersecting. It means this system, whatever the system represent this plane, have no solution. See, there is one case.
Got it, sir. Got it.
Planes are like this. Suppose this plane and this plane. If the planes are intersecting like this, so
solution.
No. So in this case, have infinitely many solutions. Why?
Yes. Because there are one lines in the intersection.
They will intersect on a line. See, two planes are cut, then there will be a line, right? There will be a infinitely many solution possible, right? See, this is they will intersect like this. Let me show in GeoGebra. Just let me go. If you are confusing, let me go. Then maybe this is YouTube. No need to this one. GeoGebra.
In the tutorial,
if you see in tutorial, clearly explain, I think. Yeah, this question is actually based on tutorial. If you watch it, I forgot to tell you watching the tutorial also. So watching the lecture, please watch the tutorial. There maybe some concept are missed. So you need to watch the tutorial. In tutorial also, there will be some concepts. So actually this concept of plane is using in tutorial, based on the tutorial only. If you watch the tutorial, it will be very much clear to you. So what is happening here? Our case is the case is here z equal to, for the question is z is equal to 1 and z is equal to 5. This case is happening, and these two planes are not intersecting. Suppose the case is x is equal to 2. So see, these two planes are intersecting. So, and see that this is a line. These two planes are intersecting on a line. These planes are infinite. So they are intersecting on a line, right?
Yes, sir.
It means if the points are here, it will satisfy both plane. It means this equation, suppose z is equal to 1 and system of linear equation z equal to 1 and x is equal to 2. This system has whatever the points values here will lie, it will satisfy both equation. And there are infinitely many points. That means this system has infinitely many solutions. Suppose for unique solution, it will be like this. Y is equal to, let's say, y is equal to 2. Then you will see that in the case of here, these three planes are intersecting at this point. So in this case, have a unique solution. So please watch tutorial. Let me more precise in the tutorial.
Got it, sir.
Yeah, am I audible now? This is Virat.
Yeah.
Yeah. Exercise activity question 1.3, question number 10.
1.3 question number. This is the same activity. Question number 10.
Yeah. In this, if you solve system 1, system 2, that is pretty easy. You will get 4 values. But by doing matrix, can it be solved?
Using matrix, it will be difficult, because if you will collect with this,
you can solve it, but the concept was not covered in week 1.
Actually, yeah, it can be done using Gauss elimination.
Yes, Gauss elimination.
But this question is given to only to solve this separately. Find the value of x1 and x2. Solve yourself and then put the values and check what will the possible. That's all. This is the mean of the question. Otherwise,
I was trying with matrices and I was not able to do it.
Actually, so connecting with the matrix, it will be difficult. It will be the 4 into. It will be the matrix will be 2 cross 4 something, and it will be difficult.
Okay. So next question is activity question
Sir, may I ask on this only a clarification? That means we have to first solve each of these set of two
system.
equations.
These two equation and put the values according with that and find the value of m and n. That's
okay. Thank you.
Start to activity session is scheduled at 8 p.m. sir.
Stat 2?
Yes, sir. Live class at 8 p.m. today.
So okay, so if you are joining stat 2, you can, I will say you can first ask your question and then let me
Sir, I want to ask a small doubt in activity question 1.4. 1.4, sir. Question number 8.
Question number 8. Question number 8, okay. This one.
Sir, what is the best way to solve this question? Suppose you have given the hint and I solved it in terms of A and B, and then at the end I put the values of A, B, and C in there and got the answer 2000. So it has to be done like this, or is there any other way to do it?
Yeah, actually this is the, see, numbers are given as similar to here the entries, B kind of C. So actually you need to use the elementary row operation are given, and what are the effects when you do when you are doing row operations.
Sir, I don't know. I'm not getting that concept. Can you explain this question using that concept?
Yeah, so you are expanding only, right? This is A, B, B, C, something is there. What is that? Let me make it.
Yes, I expanded it in terms of A, B, and C, and then put the values and got the answer. This was the way I did it. But
no. So you actually, this question is given for the purpose of using elementary row operation. Let me tell you how you will go.
Yes.
Suppose this is given. See, that whenever such kind of questions are there, expanding will be difficult. See, you know that if there is a matrix, so try to make it all are in the first row or any column, or make it 0 all and only need to multiply with the 1 and rest all become 0, then it will be easy, right? No, I mean to say you need to make it like this, try to make it 0 0 this one and only one entry left. Then if you expand with this one, you need to once needed, right? And rest all you can remove using the 0. So the first thing is this one, but this question is given for the using elementary row operation. So you can subtract with this. What is that here? 1. If you subtract this, what I mean, R3 minus R1, if you do like this, so it will be 1 AB, sorry, BC, and this is 1 BCA, and this is 0 A minus C, and here BC minus AB, and this BC minus AB can read, if you write like this, C minus A, right? You will get this one. So let's remove this, and it will be B common C minus A, and this can be written as minus B A minus C.
Okay.
So it means final thing is minus B A minus C. Now see, this row is multiple of A minus C. You can make it out, A minus C, right? Only the column, the third column, is multiple of A minus C. The next one is what will remain? A B C, 1 B C A. This is 0, this will become 1, and this will become minus B. Clear? Similarly, if you do with this one, and you can again make it out something, and here will become 0. Here will be it will become 0 also. So if you expand the determinant along this column, so it will be easily and can be done also. Clear?
Yes, sir. I will try it once more, sir, and then.
Okay. So.
Sorry, activity question 1.2.
1.
Question number 6.
Question number 6.
Why option 1 and 2 not correct? Actually, so many people have asked in Discord also.
Okay, 1 and 2 is not correct. Okay, this is for matrix. Okay, let me check. What are the options are not correct? Question number 1 and 2 is why option 2 in okay. Then A equal to 0. Okay. Are you? Is it true that if a square is equal to 0, then a will be 0?
Means it is not a necessary condition. It can be.
It can be. It can be. Yeah, it can.
Yeah.
But there are some matrices. If you multiply, you will get 0.
Yes, that is right. But this sentence framing is means it is not written anywhere. It is necessary true. Like this, people are getting confused. Means if you read this statement,
if A is a square matrix of order 2 and A square is equal to 0, then A equal to 0.
A is equals to 0. Then it could be one case.
It would be one case.
One case.
It is one case, but the option mean to say options are like for the choose the set of correct option. Choose the set of correct option, and it's the same option I am writing like this. Okay, I am assuming same. I will not change anyone. A is a square matrix of order 2, and a square is equal to 0, where A is 0, 1, 0, 0.
Correct.
If for this case, this statement is will not true, right?
Right. This statement is not true for this case, but the framing of the statement is means this statement is true. If you if it is not in this fashion, and if you ask somebody if A is a square matrix, A square is equals to 0, then A is 0. Yes, it is true. A is equals to 0. Means it is not necessary. Means somewhere it should have mentioned it is necessary or not, like this, because so many people have asked in discourse also.
No, actually, this is also happening, right? If this is A is equal to 0 and A is equal to 0, 1, 0, 0. So see, this is not always true. This
is not always true. But somewhere it should have written it is always A is equals to 0. Always word should be there, because it is getting confused. Both the options, option 1 and option 2, both options are like this only.
Okay. See, then you will say I'm saying for this option, there are some option. Okay, there are some option. The other option can be true also for different matrix. For which option is always true? See, this question for given a general matrix, that's why you are applying on the general constant and assuming that okay, this is happening. But there are some matrix also which first and second. First, the different option can also true for different matrix. So can you assume that then that option is also true? My question is like that. See, this for particular case can be true. For general case, this can also be sorry. For general case, only these two options will be true. For particular case, all option can be true, but you are not choosing. Why? Because this is given a general case. The same is happening also here. This is one a particular case. We are getting a different analysis. So how it can?
Okay. So because the hint it is mentioned in general, means the hint.
Assume here it is in general case is given.
Okay.
Not but the hint is different thing, but options are like to be always true, means the options are the same case as here is happening. For particular case, for particular matrix, all options can be true. So here is also happening. For particular it is true, but for general case is not.
Yeah, I agree. For general case, there could be other cases also.
Yeah.
And one more question, number 8.
Sir, option 1. Can you explain option 1?
If A is a square matrix of order 2, A square is equal to identity, then A is equal to I or A is equal to minus I. Is that always?
No.
You can neglect with the different diagonal also. See, case is true, no issue. This is true. But you can neglect with the different matrices also. There are some matrices which true for the case this one, but we are getting not exactly I. So how this option can be true? This option is says if this, then this is only. I mean, this is only if this is happening, then this is. But we are getting a different also. So how this option can true?
Okay. Okay, sir. In general, it's not true.
Sir, activity 5.
Sir, I have one more
Last
question in this same exercise. Question number 8.
Okay. Yeah.
Just hold out. Yeah.
Question number 8. Okay.
In this, the last option, a square plus a plus I. How to go about this? Means if it is true, means how to find out? Means how to solve this kind
You
of?
can inverse matrix. You can find the inverse.
No, but actually it is not given for the inverse. It is not say inverse is exist. We need to find some non.
Okay.
So
Okay,
you have to go with the general case. So that is why hint is given that you assume A is equal to this and use the condition. Let me tell you how we will approach. What are the hints mean also? Maybe many times you may confuse also. Only this is given. It is given that hint is says use assume A equal to A11, A12, A21, something whatever. A equal to and the apply case. Let's assume A equal to, I am assuming not A11 because of this writing always A12. Let's assume A, B, C, D. Assume this one. This is the our A. What will be A square? It will be A, B, C, D. This is equal to this
A square.
It will be
A square BC
plus BC
plus BC.
No.
AB
plus
AB plus BD.
BD
plus BA.
And what is the next?
AC plus BC.
BC.
BC plus
AC plus
DC.
DC. Sorry, DC. And this is the
BC plus BD.
BD. So we have A square this one. So A square plus A plus I equal to 0. What it mean that? It will be case here. If you add this one with the A plus I, we will get here A square plus BC plus A plus 1. AB plus BD plus B.
B plus only B.
AC plus BC plus C. And here is BC plus BD plus D plus 1. This will be the A square
0
identity. And this is equal to 0. So what it compare it with the 0 means 0, 0.
I can write 0 matrix. Yes.
It means A square BC plus A plus 1 is equal to 0. And the second one is here. Let's write here. AB plus BD plus B equal to 0. AC plus DC plus C equal to 0. BC plus BD plus D plus 1 equal to 0. We are 4 cases. This is not a linear equation, but we want to find a matrix, real matrix. Real means entries should be real number.
Correct.
Okay. So if you observe here this, see from these 4 matrix, these 4 equation, we have to find a matrix. Then we can conclude, oh, there is a real number, there is a real matrix or not. Okay. If you observe these 2 matrices, you can take here B common as B plus D plus 1 is 0. And similarly here C, A plus D plus 1 equal to 0. Right?
Correct.
Now this says either B is equal to 0 or A plus D plus 1 is equal to 0 or both can be. Also?
Yes.
So assume that B equal to 0. Similarly for here C equal to 0. So what will happen here if you assume B equal to 0 and C equal to 0, or B at only B equal to 0 and A plus D, no, the case is B equal to 0. If you assume that, B equal to 0, then what will impact here? A square plus A plus 1 is equal to 0, the first equation. And we want a real number. So is the case here, this equation give real number for A, for value?
It gives a complex.
No.
It will never give.
Complex.
So it means that we should not take B equal to 0. We want a real case. We should not take B equal to 0. It means we should to take A plus D plus 1 equal to 0.
Okay.
So it means let's change it to with the A as a D, A equal to minus D minus 1. So see, actually we shifted A as a minus D minus 1. Okay. Now let's back to here. Here again, as we have B equal to 0. Sorry, B as here we got A plus D plus 1 equal to 0. Okay. So if you see that here, this equation, if you take common, is there anything is common?
Common not possible.
Common is not possible. Okay.
Whole common not possible, but we can B or D. We can take D. BD plus D.
BD. Okay. A equal to
BC plus BD. We can take B.
Just 1 minute. I'm missing something. B plus here is A, B, and BD. Okay, we infer from here. C can be. Okay, we got A equal to and B equal to B. Let's take this one. B. Let's take this one. This BC plus B equal to what will be here? Minus D minus 1. Right. So if you take B common, it will be C plus D equal to minus D minus 1. Okay. This implies B equal to minus D minus 1 upon C plus D. This you will get. Actually, what I am trying to do, we have A, B, C, D, and we want a real entry of A, B, and C. So I am trying to reduce this 4 entry with the only this B, C, and D. Otherwise, you can change with the A also. What I mean to, I want to time A as a equation of C and D and B as a equation of C and D. So final thing is we got A equal to minus D minus 1. Okay, B as minus D minus 1 upon C plus D, and C and D as it is, and give any real number to C and D. You can give any C equal to 1, D equal to 1. If you check after substituting, and if you check this equation, you will get 0.
Yeah, got it. We have to find out a way to make all those 4 equations.
Using 4 equation, we got this equation. Using 4 equation, you have substituted some values, and if you when you see, this is a general matrix. There are, what it means, there are infinitely many real matrices which satisfying this equation, right? You can freely give C and D some value, and you can deal with the, you can get that, yeah, okay, A square plus A plus 1 is equal to 0. You can check actually. Actually, this one, this time I got this one when I was trying myself, I got some different also. This equation with this equation is some different also. It's depends on you how you are solving using these 4 equations. Then you will get A square plus A plus 1 is equal to 0. Otherwise, no. Okay.
Yeah, got it.
So tomorrow you will be taking the class?
Tomorrow is Susmita ma'am is going to take. Actually, you will get a very good feel. She is just to be taught very, very well, very good.
Sir,
activity 5.
Okay, so same activity both. Okay, activity 1.
Activity, last question.
Okay. The same, this one.
Yeah. So here it's a cube root of determinant of A square B. So it is like cube root of determinant of A square into determinant of B. Right. So next it is like, so determinant of A square, I can put as determinant of A the whole square.
A whole square. Okay. No, I still remain. See.
A of B square.
Actually, see, we need to be like here. Determinant of A square B equal to determinant of A square into determinant of okay, you said whole. Okay, determinant of, this will get
Okay, so that means determinant of A is so can I go back to the question? It's determinant of A. Okay, determinant of A is given as 4 and B is given as 3A, which is equal to 12. So it should be determined that it should be 4 into 4 into 12.
No, not equal to 12. It will not equal to 12. Again, the same meaning is. Actually, 3 times A means what will be? 3 times A, 3 times B. All entries is multiply with 3, not only single one. Not only single row also.
Got it, sir. Got it.
So actually, let me write a formula. C times A, and A is suppose n cross n matrix. So the relation is it will be C power n determinant of A. The formula.
Yes, sir.
This will happen always. C is any scalar, A is n cross n matrix. So determinant of whole equal to C power n determinant of only A. This is the formula.
Okay, sir, if determinant of A, for example, if determinant of A is given as 2, then determinant of A square can written as 2 into 2, right?
2 determinant of A square, that is 2 into 2. Okay. This is the formula also, determinant of A into B equal to determinant of A determinant of B. So A square means the whole square it will apply a determinant of A whole square.
Okay, got it.
Excuse me, sir. It could be a determinant of C into the matrix could be n by any other number, right? It could not necessarily rectangle square matrix.
No. So determinant case is only for square matrix, not for.
Oh yes. Sorry. Got it.
Okay. So somebody says same activity with the different question or same question? I don't.
Yes, sir. Question number 1.
Question number 1, can you explain?
Hi, I will
activity.
Yeah, let me finish this one. This question number, which question?
Question number 1, option 4.
Option 4. If A is a real 3 cross 3 matrix, then order of all possible square matrix of A are this.
Yes, sir. So why 3 cross 3 is also there?
Yes. That is the submit.
A is a real 3 cross matrix, then order of all possible square sum matrices of A. Okay. Actually, see, you know that a set is subset itself.
Yes, sir.
So this is the case here. A is also itself a submatrix, right? Because I'm not deleting anything, only the same as. Or you can say 0 row and 0 columns I am deleting only. Still we will get the same. That's why 3 cross 3 is happening. The same case as a set is subset of itself. So the same as here is happening.
Okay, thank you. Sir, activity questions are 1.1, question number 8.
1.1. Question number 8.
Sir, I'm doubting one option.
Option 1.
No, yes, sir. No. B4 represents a scalar multiple of A plus B.
Just now we discussed this.
Sir, I could not get it. Can you explain again?
Actually, what is happening when you are adding A plus B, what you will get? What will be the vector A plus B?
A plus B. Vector A plus B, maybe B3 also?
No. Here is value is given also, right? Here is A is minus 1, 2, B is 2 minus.
Okay, sir. Here we will get 1 plus 1 0.
1 0. 1 0 is where lying, if you will say, it will lie on line.
On x-axis.
On x-axis.
Yes, sir. And
V4 is not exactly given, but V4 can be minus 1 0 or maybe minus 2 0. Anything can. So that's why he's saying V4 may represent or V4 represent a scalar multiple of A plus.
Okay, sir.
Okay. So yeah, somebody has have doubt.
1, 4, and 5. Question number 9.
The same activity. 4 and 5. Activity
1, 4, and 5.
1.5. Okay. Question number
9.
9. Okay. What is doubt here?
Sir, how to find matrix B?
How to find matrix B? Yeah, actually B is 3 cross 3 matrix where ijth entry is given always equal to Cij. And what is Cij? Cij is written here is the cofactor.
Yes, cofactor. So B matrix is 3 cross 3. So I can find C11, C12, C13.
Actually, you have to find each entry of entries of B using this whatever is
cofactor for each entry.
C31 I can't find it.
C31, why C31 will be here. So it will be deleting this one, it will be the determinant of that. So it is -1. And here will be minus sign will come because it is cofactor is saying. So one entry. So one is coming.
So -1 only, no? 3 plus 1 is 4.
Cofactor means
-1.
Plus minus plus. Oh, sorry. -1 will come.
Yeah.
Okay, got it, sir.
Okay.
Thanks, sir.
And anyone else? Yeah, from a long time I didn't see chat. Okay. So I don't know who had session have got cleared of this cleared or not. I don't know.
Excuse me, sir.
Huh?
Can I like this question you have discussed, but still have some doubts that when you add two system of linear equation, what happens to the solutions? They also get added. We can remember this like as a general identity. Like if we add the system 1 has solution x1 and system 2 has solution x2, then if we add it will be x1 plus x2, or if we subtract then it will be x1 minus x2 accordingly.
Okay, let's see that. Okay, you are saying a system a1x equal to b1 is a solution as let's say
x1.
Okay, and a2x is equal to b2. This has solution x2.
X2, right? So if I do
so let's
a1
add
plus
this
a2.
Let's add this one a1 sorry, here will be a1 plus a2
whole x
with the same is coming. Okay, coming. So it will be x is equal to it will be b1
plus b2. Yes,
plus b2.
Yes,
we have here ax1 equal to b1, ax2 equal to b2. So here we got ax1 plus ax2. So you are saying x1 and x2 will be solution or not, na?
Yes, sir. This is what I want to confirm.
Okay, let's take here a1 plus a2. So we want to check means we have to take left side and substitute the value of x. So it means it will be x1 plus x2. And if we are taking left side, we are getting this right side or not. Only need to check. This is the main. So what it means that now it is as usual as multiplying with like this ax1 plus ax2 plus a2x1 plus a2x2. This will we get. This we will get. This is the happy.
X1, X2. Yes, sir.
And this is B, but we don't have any idea about this one.
A2x1, AX2.
AX. No, sorry, here is, I missed it. A1.
A1, A2.
A2.
Sorry, A1 you
don't have idea about A1, X2, right? Here is, this is it. No, we don't have any idea. So it will not work. It may or may not. For particular case, it can work, but for general case, it may not, because this is, we are not getting this value. How we will get? This is A1. But yeah, we have this one. We also are, we are not getting this value. We have this one. This is,
Two new terms have come up.
The new terms are coming, so we cannot generalize it.
Okay, so we cannot generalize it. Thank you.
Okay. I don't know many of you got cleared your doubt or not. Okay. Somebody has posted 0.2 is question number 1 and 3. 0.2. Quick. Nachiket, can you unmute? Yourself can ask. I'm not. 0.2 means what? 0.28. Nachiket, are you able to hear me? Okay. I don't know. I'm not getting what he's writing. 0.2 weak, 0.28. Okay. Anyone have doubt? Or it's 2 hour over. Going to be more also. 2:23. I don't know. Many of you got clear your doubt or not. If you have doubt, you can ask, or we can let's close the session now.
So 1 minute, just 1 minute. So 1.2 last question. Can you just give the idea? I tried it, but maybe I made some calculation mistake.
1.2.
Yes, sir. Like we have to solve this individually in part and add them, right?
You actually you have to like find the a square, like
alpha,
and compare, like add the entry wise, and find the final thing in right side and equate with the 0 matrix.
Sir, actually in this question, I'm getting the alpha value as -2, but in the answer it's something different. 6.
Like, yeah, I'm also getting wrong alpha, but I'm supposing maybe some calculation mistake.
What value are you getting? -2, is it?
I got 1.
Okay.
6 into alpha minus 1
Answer,
equals,
and whatever the answer is here, 6 is correct.
yes.
I am not saying, but yeah, this is correct. If it is wrong, it's surely someone have.
Just like there are quite many calculations, many plus minus multiplications.
So actually, you need to find correctly a square and then add like that. Okay.
And number 9, sir. Number 9. 1 second.
In this actually, B is clearly said what will be B, and also information given about A. A is actually a diagonal matrix.
Diagonal matrix only.
So what it means that all entries come in diagonal only, and rest all are become 0. The non-zero entries will come in diagonal only, and rest all 0. And diagonal entries will be same. That is the mean of diagonal. So if suppose
the
first one is given
comes out 444, right?
444. The second is already given what will be the entries, and just add
8.
And find the 2. That's it.
So mine is coming to be 16, but answer is 8.
Actually, answer will be 8 itself, because if you see that 2, what will be the 2? Here will be 4 plus 4. Oh, sorry, just 1 minute. It will be.
Oh, sorry, mine is coming 8, but answer is 16.
Answer is actually will come 16, right? What will be the 2 entry of B? It will be 4 plus 4,
plus
8.
4, 8. Yes, sir.
And what is the entry at of 2 at for A? It will be
A is 4.
4. 2 times 8 will be 8, right?
Okay,
Each will be
8 plus 8, 16.
It will be a diagonal matrix of 8.
It will be a diagonal matrix with the entries. So that's it. Okay. So let's end the session. Okay. Thank you so much for joining.
Thank you, sir. Thank you, sir.
Thank you, sir.
Good night.
Good night to all of you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Hmm.